So good morning my dear students. So logarithms part 2. So these are the 9 fundamental laws you have to remember. Okay. The first law is what? Log of mn to the base a is equal to log m to the base a plus log n to the base a. That is, we are converted product to sum. So here it is a product of how many numbers is there? 2 terms is there. Even it is 3, 4, product of any finite number of terms is also there. This formula holds. Okay. For example, log of m into n into k can be written as log m to the base a plus log n to the base a plus log k to the base a. Log of m n k, m into n into k to the base a is equal to log m to the base a plus log n to the base a plus log k to the base a. Okay. So a may be any permissible number. Okay. So quotient log of m by n to the base a is equal to what? Log m to the base a minus log n to the base a. And third, this is the important, log of a power m to the base b power n is equal to what? M by n log a to the base b. Particularly if n value 1, then this formula holds. This formula reduces it to what? Log of a power m to the base b is equal to m times of log a to the base b. In this formula, if m value is 1, then formula reduces it to what? Log of a to the base b power n, base b power n is equal to 1 by n into log a to the base b. And already we did this. Log 1 to the base a is equal to what? 0. Log of 1 to the base a is equal to what? 0. Log of a with the same base is equal to what? 1. Okay. Log a to the base b can be written as log a by log b, or it can also be written as 1 upon log b to the base a. In 6th and 7th formula, a and b should be positive other than 1. Okay. And this is the important formula, 8th and 9th. Based upon 8th and 9th, last year 2019, one advanced problem is given in logarithms. Okay. So based upon we have based upon 8th formula and 9th formula. Okay. 8th law and 9th law. A power log x to the base a is equal to x. See here base a. So if you treat it is look like a power x. So the base is a. In this logarithmic function also the base is a only. Then whatever the argument is there, then that will be the answer. For example, what is a 7 power log 9 to the base 7? 7 power log 9 to the base 7 is equal to what you will get? 9. Okay. Next, 9th formula. A power log b to the base c is equal to b power log a to the base c. That means we can interchange the positions of a and b. So base must be same, c only. For example, 3 power log 2 to the base 3 can also be written as 3 power log 2 to the base 4. You take better. Okay. So 3 power log 2 to the base 4 can be written as 2 power log 3 to the base 4. Both are same only. Okay. Next, I am going to prove only one fundamental law, that is the first fundamental law. Remaining you only solve it. Remaining you will try. But you have to remember all these 9 laws. So you have to remember all these 9 laws. Okay. So I am taking, let it be this quantity is equal to x. That means I am taking log of mn to the base a is equal to x. Okay. Then this is the logarithmic form. I am going to convert it to exponential form. Log of mn to the base a is equal to x means this mn is equal to what you will get? This mn is equal to what you will get? A power x. Okay. Next, let log m to the base a is equal to y. Convert it into exponential form. What you will get? This m is equal to a power y. Next, let log n to the base a is equal to z. Then what you will get? N value a power z. N value a power z. Now according to this law, we have to prove that x value is equal to y plus z. Okay. Now look at the first equation, m into n value, what we got? A power x. M into n value, what we got? A power x. But what is m value? A power y. What is n value? A power z. Substitute here. Then what you will get? A power y into a power z is equal to a power x. A power y into a power z is nothing but a power y plus z is equal to a power x. As bases are equal, exponents also equal. So thus what you got? X is equal to y plus z. But what is x? Log mn to the base a. So log mn to the base a is equal to y value, log m to the base a, plus what is z value? Log n to the base a. So thus this is the proof of first law. Similarly, you try for remaining laws. Now I am going to start problems. So the first problem is solve the equation for x. Solve the equation for x given that 1 by 2 whole power x square minus x square plus x square plus x is less than 1 by 4, less than and greater than. Solve for x. 1 by 2 whole power x square plus x is greater than 1 by 4. So that means we have to find the set of real numbers x satisfying this inequality. 1 by 2 whole power x square plus x greater than 1 by 4. So you try to express this RHS also in terms of 1 by 2 powers. Okay, because LHS is 1 by 2 something is there now. So that's why. So 1 by 2 whole power x square plus x greater than 1 by 4 can be written as 1 by 2 whole square. 1 by 2 whole square. So it is look like, situation is look like a power x greater than a power y. Correct? Situation is look like a power x greater than a power y. So this can be written as x greater than y only when a is greater than 1. Or then this can be written as x less than y when a is less than 1. Okay, a power x greater than a power y implies that x greater than y only when base a is greater than 1. A power x greater than a power y implies that x less than y when a is less than 1. It is because of when a greater than 1, a power x is an increasing function. So that's why after removing the function also inequality remains same. When a less than 1, a power x is decreasing function. So that's why after removing the function, inequality changes. Here what is a value? 1 by 2, less than 1. So that means after removing the function, inequality changes. So then what you will get? X square plus x. So this symbol has to change. So has to change means a greater than symbol becomes less than. If it is less than, then it becomes greater than. So x square plus x is less than 2. So x square plus x minus 2 is less than 0. So find the factors. Okay. So first make the highest x power coefficient is positive. It is already positive. Then you take the factors. You will get x plus 2 into x minus 1 is less than 0. So what are the roots? Minus 2 and 1. So what you will get? Plus here, minus here, plus. That means x plus 2 into x minus 1 less than 0 is possible when x is lie between minus 2 and 1. So thus x belongs to open interval minus 2 comma 1. So the solution for given inequality is what? Open interval minus 2 comma 1. X belongs to open interval minus 2 comma 1. Next, second problem. Second problem. Solve 1 minus 5 power x divided by 7 power minus x minus 7 is greater than or equal to 0. So first you make the this exponential function coefficient is positive. Okay, make the coefficient of this exponential function is positive. To make it is positive, we have to multiply with -1. If you multiply with -1, as -1 negative number, so then inequality will be changes. Okay, so if you observe, 3 is greater than 2. Am I correct? If you multiply with -1, what you will get? -3, -2. So greater than symbol becomes what? Less than only, because -3 less than -2 only. So that means if you multiply with a negative quantity on both sides of the inequality, inequality will be changes. Okay, if you multiply or divide with any negative quantity, inequality sign will be changes. Okay, so then this can be written as 5 power x minus 1 by 7 power minus x minus 7 less than or equal to 0. So clearly the numerator 5 power x minus 1 will be equal to 0 when x value is 0. Correct? And clearly the denominator 7 power minus x minus 7 is equal to 0 only when x value is minus 1. Correct? Huh? So numerator will be 0 when x value is 0, denominator will be 0 when x value is minus 1. So at this point this total function is 0. At this point the function is not defined. So just you identify those 2 points on the real line. At -1 it is not defined, so you keep the circle here. This circle indicates the function is not defined at this particular point. So in this problem -1. And the numerator will be 0 when x value 0. So same alternatively plus minus plus. So plus minus plus, correct? So now you tell me where this function is negative between -1 and 0. But here we have what? Only less than 0 or less than or equal to 0. Equal to 0 also there, na? And when this function is equal to 0, when the numerator is 0. At which point numerator is 0? When x value 0. That means this function is negative when x is lie between -1 and 0. And this function is equal to 0 when x value equal to 0. So thus the solution of this inequality is what? X is lie between -1 and 0. 0 also included. So thus x belongs to interval -1, 0, 0 included. Next kind of problems, we have to find which of the following quantities are positive, which of the following quantities are positive or negative, which of the following quantities are positive or negative. So the question is a log 7 base 2. So we have to check whether this quantity is a positive number or negative number. So for that sake, let it be x. Let x is equal to log 7 base 2. You convert it into exponential form, then what you will get? 7 is equal to 2 power x. 7 is equal to what you will get? 2 power x. Or 2 power x is equal to what you will get? 7. So clearly 7 is greater than 1 only, na? Clearly 7 is greater than 1 only. That means 2 power x, what you got? Greater than 1. So 2 power x greater than 1 means x must be greater than what? 0. Because 1 can be written as what? 2 power 0. So base anyway greater than 1. After removing the function also inequality remains same. So x greater than 0. X greater than 0 means what? Log 7 base 2 is positive number. Log 7 base 2 is positive number. Next, one more example. Log 3 to the base 0.2. So we have to check whether it is a positive number or negative number. So same, let it be x. Then this 3 is equal to what you will get? 0.2 whole power x. 0.2 whole power x. So clearly 3 is greater than 1. Nothing but 0.2 whole power 0. Why I have taken 0.2 only base? Because your base is 0.2. So 0.2 whole power x is equal to 3. 3 is greater than 0.2 whole power 0, which is nothing but 1 only. Okay. So now what we got the situation? 0.2 whole power x greater than 0.2 whole power 0. Okay. Now the base 0.2 is less than 1. So that's why inequality changes after removing the function. So thus what you will get, x is less than 0. So thus log 3 to the base 0.2 is a negative number. Okay, so we can solve this. Then I am giving one more problem, one more variety of problem. So log of 1 by 5 base 1 by 3. So we have to check whether it is a positive or negative. So same, let it be x. Then what you will get, 1 by 3 whole power x is equal to 1 by 3 whole power x is equal to 1 by 5. Correct? So 1 by 5 is less than 1 or greater than 1? It is less than 1. So 1 by 3 whole power x is less than 1 means nothing but 1 cannot be adjusted like 1 by 3 whole power 0. Why we are adjusting like 1 by 3? Because here the base is 1 by 3. Now the base 1 by 3 is less than 1. After removing the function, inequality changes. So thus what you will get, x greater than 0. So thus log 1 by 5 base 1 by 3 is positive. Okay. So next one more variety of problem. Log of 1 by 3 base 4. So same steps you take, let it be x. Then what you will get, 4 power x is equal to 1 by 3. 1 by 3 is less than 1, nothing but 4 power 0. So 4 power x less than 4 power 0. Base 4 is greater than 1. So after removing the function, inequality remains same. So thus what you will get, x is less than 0. That means log 1 by 3 base 1 by 4 is negative number. Okay. So either you can do the you can check like this also, or you can remember one inequality also. Log x to the base a is positive only when both x greater than 1, a greater than 1, or both x and a less than 1. Okay, log x to the base a is positive both x and a greater than 1, or both x and a less than 1. If it is opposite, negative. That means opposite means if x greater than 1, a is less than 1, then log x base a is negative. When x is less than 1, a is greater than 1, log x base a negative. Okay. Now if you observe, in first case, what is x value? 7, a value 2, both are greater than 1. So then what you will get, log x base a is positive. We got no positive value. Even in even in a third problem also. So here what is x value? 1 by 5. What is a value? 1 by 3. Okay. So if we compare this problem with this situation, this formula, this inequality, then x value what you will get? 1 by 5, a value 1 by 3. Okay. So both are less than 1. Then log 1 by 5 base 1 by 3 is positive quantity. So that is what we got here. Okay. If it is opposite, that means one is among these two quantities, one is less than 1, other one is greater than 1, then log x to the base a is negative. See here, x value greater than 1, so this value greater than 1, this base is less than 1, then what you got? Negative. Next here also, here this quantity less than 1, this quantity is greater than 1, what you got? Result? Negative. Okay. Next. So that means to solve those kind of problems, you have to remember this formula. Log x to the base a is positive only when x greater than 1, a greater than 1, or x less than 1, a is also less than 1. To be understood, they are positive. And log x to the base a is negative when x greater than 1 and a is less than 1, or x is less than 1, a is greater than 1. In these two cases, to be understood, they are positive also. Okay, 0 less than a less than 1. A less than 1 means 0 less than a less than 1. Here x less than 1 means 0 less than x less than 1. Suppose if I, by looking this problem, suppose if it is given like this, log 8 to the base 10, whether it is a positive quantity or a negative quantity. So both x and a greater than 1. So it is positive. Suppose if it is like this, log 1 by 8 base 1 by 3. Here x value 1 by 8, a value 1 by 3, both are less than 1. Again, positive. So log 3 base 1 by 8 is there. So it is negative because 1 is greater than 1. X value 3 greater than 1. A value 1 by 8 less than 1. So automatically log 3 base 1 by 8 is negative number. Okay. Next problem. So find the value of log of 512 base 2. Next, log of base 3 means log of base 3, log of 512 base 2. To get this value, first you calculate this value, this inside the bracket value. So log of 512 base 2. Okay. So anyway, base is 2 is there now. Is it possible to express 512 also in the powers of 2? Yes, it is possible, because 512 can be written as what? 2 power 9 with the base 2. Using log of a power m formula, what you will get? M into log a, m into log a, 9 into log 2, base 2 as it is. So using the formula, log a base a is 1, so log 2 base 2 is 1, 9 into 1 is 9. So thus this inside bracket value, what you got? 9. Okay. So it is same as log 9 base 3. Now base 3 is there now. So is it possible to express 9 is in the powers of 3? Yes, it is possible. So 9 can be written as 3 square. So again, using the same formula, log of a power m formula, what you will get? M into log a, that is 2 into log 3 base 3. 2 into log 3 base 3 as it is. Okay. So it is equal to 2, because log 3 base 3 value is how much? 1. So 2 into 1, 2. So thus log of base 3, log of 512 base 2 value is how much? 2. So next problem. Just I am doing the problems based upon those fundamental laws. Okay. So find the value of, prove that 1 by log n base 2 plus 1 by log n base 3 plus 1 by log n base 4 plus and so on 1 by log n base 50 is equal to 1 by log n base 50 factorial. 50 factorial. I think you are familiar with factorial. 50 factorial means what? 1 into 2 into 3 into 4 into 5 into 6. 50 factorial is what? 1 into 2 into 3 into 4 into and so on up to 50. So product of first 50 natural numbers. Okay. So to prove that LHS is equal to RHS, so first you take LHS. Okay. And don't take LCM. So here use log a to the base b is equal to log a to the base b is equal to 1 by log b to the base a. Use this fundamental law. But you have to apply ulta. 1 upon log b to the base a can be written as log a to the base b. That means the positions a and b will be changes. So that means 1 by log n to the base 2 can be written as log 2 to the base n plus 1 by log n base 3 can be written as log 3 to the base n. Similarly, next term log 4 to the base n plus and so on log 50 to the base n. So anyway, base in all the terms base is same. We can use log a plus log m plus log n is equal to log of mn. Log m plus log n is equal to log of mn, or log m plus log n plus log k is there, log of m into n into k. So using that formula, what you will get? Log of this becomes 2 into 3 into 4 into and so on into 50 to the base n. So for this product, if I multiply with 1 also, is there any changes in that product? So nothing will be changed. Nothing will be changed. Okay. So why I am multiplying with 1? See here, now if I multiply with 1, then it becomes what? 1 into 2 into 3 into 4 into and so on 50. Product of first 50 natural numbers, that can be written as 50 factorial. 50 factorial. Base n as it is. Now again use this formula. Log a to the base b can be written as 1 upon log b to the base a. Then what do you get? 1 upon log n to the base 50 factorial, which is RHS.